everyone, welcome to another video. We'll be discussing about quantum mechanics. We have done one video on it, and in that video we were studying about operators. So we'll be continuing our study on operators. So I gave you a question. Question was so that so that the commutator of two Hermitian operators two Hermitian commutator of two Hermitian operators is anti-Hermitian. Okay, so this is one of the questions I gave you for homework, and how to solve it. So, for example, A and B are two Hermitian operators. If A and B are Hermitian operators, so A and B Hermitian means A dagger is equal to A, B dagger is equal to B. Okay, all right. A dagger is equal to A, B dagger is equal to B, and okay. And their commutator. Commutator of two omission is anti-omission. Commutator, let's do the commutation of it. Just a second. Commutator uh, AB commutator AB dagger is equal to AB minus BA dagger. Okay, so if I open it, it will be AB dagger minus BA dagger. Now AB dagger we know is B dagger A dagger, B dagger A dagger minus this one is what? A dagger B dagger. Is it all right? Okay, now we know these are Hermitian. Hermitian means B dagger is equal to B and A dagger is equal to A. So B dagger is equal to B, A minus A dagger is A, this is B. Okay, so this is, if you see, I can write it also as AB minus BA. Okay, so this can be written as the commutation of A and B. Okay, the commutation of A and B. Is it all right? So if you see, this commutation is anti-Hermitian. Why? Suppose A dagger is equal to minus A. That means what? That means this A is, we can say A is anti-Hermitian or skew-Hermitian, isn't it? A is anti-Hermitian. So exactly AB dagger is equal to, if it is minus AB, then I can say, if this, for this minus I can say AB commutation is anti-Hermitian, isn't it? So commutation of AB is what? Anti-Hermitian. Is it all right? Okay. So this is the proof. So the commutator of two Hermitian operators is anti-Hermitian. Okay. Yeah, that's the answer. Okay. Next question was what? Question number two. Question number two was, evaluate the commutator. Evaluate the commutator. Evaluate the commutator A, comma BC, comma D. Okay, evaluate the commutator A, comma BC, comma D. So how will we do it? See. Okay, sorry, there is no comma here. Okay, see, if you remember, if this is like this, so what I said, first take this one to the left, this one to the right. Whatever is there in which side, that will come to that side only. So B AC plus C will go to right. So AB C. Is it all right? BAC plus ABC. So here, if you see, I will first take it out to the left, and plus this one will go to the right. Okay, so let's do it. So the commutator is A, comma, B, C, and D. So that will be your BC will go out. So BC and BC, that is AD, plus your A, comma, BC, and that will be your D will go out. Isn't it? D will go out. Okay. Now if you see, BC can be written as BC minus CB. Okay, and AD can be written as AD minus DA. Okay, plus again I will open first. I will open the inside part. Okay, so comma A, comma, BC minus CD, sorry, CB, and your D. Okay, so if you see, I will multiply it. This will be BCAD minus BCDA minus CBAD minus, so minus plus CBDA. Okay. Now I have to open this one. A, comma, BCD minus A, comma, CBD. Okay. Now again I will have to open this one. This will go to the left side. This will go to the right side. Okay. So BCAD, this thing we have to write it again, minus BCDA minus CBAD plus CBDA. Okay, and this one will be plus, there was a plus here, plus D will go to the left, BACD, plus C will go to the right, AB, this will go to the right, CD. Okay, minus again C will go to the left, D will go to the right, so C, AB, this is D, minus minus A, comma, C, and B will go to the right, B, D. Okay, now BCAD BCAD minus BCDA minus CBAD CBAD CBAD. Just a second, I have to take a call. Hello, again, 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 sir. Jordan, so prepared over it. So କେତେବେଳେ ଆଜ୍ଞା 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 सर मैं मंथली तो 4000 କରୁଛି वीकली 5ଟା କ୍ଲାସ୍ सर 1 आवर ଦେଢ଼ ଘଣ୍ଟା କରୁଛନ୍ତି କାଲି ସାର୍ ଆକ୍ଚୁଆଲି ଗୁରୁବାର ଦିନ ବୋର୍ଡ଼ ପରୀକ୍ଷା ରହୁଛି ତ CHSCର ଫିଜିକ୍ସ ଅଛି ଗୁରୁବାର ତ ମୋର ଏଇନେ 2 ଦିନ ଟିକେ ତାକୁ ସେ ପିଲାକୁ ପଢ଼ିବାର ଅଛି କାଲି ପରଦିନ ଗୁରୁବାର ସାର୍ ଗୁରୁବାର ପରେ ହେବ Sir, sorry. 1.5 hours. Sir, ଆପଣ କିଏ କହୁଥିଲେ? ସେ ନମ୍ବରଟା କୋଉଠି କହିଲେ? କିଏ କହିଲେ? ସେ ଯୋଉ OLX ତ? ଆଜ୍ଞା। ଆଜ୍ଞା। ଆଜ୍ଞା ସାର୍ କନଫର୍ମ କରିଦେବି ଗୁରୁବାର ଇଭିନିଂରେ ହେବ 6ଟାରୁ 7:30। ଆଜ୍ଞା। ଆଉ ସାର୍ ମୋତେ ଆଡ୍ରେସଟା ଲିଙ୍କଟା ବି ଏଇ ହ୍ୱାଟ୍ସଆପ୍ରେ ଟିକେ ପଠେଇଦେବେ। ଠିକ୍ ଅଛି ସାର୍ ଥ୍ୟାଙ୍କ ୟୁ ସାର୍ ଥ୍ୟାଙ୍କ ୟୁ। ପଢ଼େଇବା ପାଇଁ ପଢ଼େଇବା ପାଇଁ ଟାଇମ୍ ଗୁରୁବାର ଗୁରୁବାର ଇଣ୍ଡିଭିଜୁଆଲ ଦେଖାଯାଉ। हाँ OLX. Okay, so I'm really sorry for it. Okay. So BCAD minus BCDA minus CBAD plus CBDA. Um, okay. So this will be B AC minus CA B plus AB minus BA CD minus C AB minus BA B minus FC minus CA B. Is it okay? Okay. So I have to open the bracket. So BCDA minus CBAD plus CBDA plus BAC. See, this D is also there. Minus BCAD plus ABCD minus BACD. And again this bracket minus CADD minus plus CBAD minus ACBD plus CAB. Okay. So if you see these two are cancelled, you can check it. See, these two are cancelled, and you can check which are cancelled here. These two are cancelled, right? These two are cancelled. And, okay. So what is left? One, two, three, four. Four terms are left. We can just write them. These are not getting cancelled. So ABCD minus BCDA plus CBDA minus ACBD. Okay, this is ACBD. This will be your answer, right? Yeah. Okay. So this is the value of the commutator that uh, A, B, C. Is it all right? Yeah. Okay. Next is the what? Next is the uncertainty relation between two. uncertainty relation between two operators. Okay, uncertainty relation between two operators. So, uh, see what is the see first of all what we need uncertainty in A suppose. So the formula will be this one average of A square minus average of A square. Okay. Now, uh, yeah, this one only. Suppose there is average of B. Suppose average of B square minus average of B square. Okay. Okay. There is another formula that you just remember. Del A into del B greater than equal to half equal to half A comma B. Okay. Expectation value of A comma B. Is it alright? Okay. Okay. Next, right now. Next is your inverse and unity operators. Okay. So see, inverse of an operator is on what? What is an inverse of an operator? Okay, inverse of an operator is suppose. Okay, see, inverse means suppose this A is a linear operator. So your A inverse will be what? A inverse into A is equal to A into A inverse. That is equal to I. Like I is your what? Unity operator. Okay. So if you take the operator and multiply it with his inverse operator, inverse of the operator, you will get it. You will get unity operator. Is it all right? Now, uh, I can write. Suppose this is like this: A divided by B. So I can write it as A operator into B operator inverse. These are simple things we know it. Yeah? Suppose there are four operators. I multiply A, B, C, D inverse. That is D inverse, C inverse, B inverse, and A inverse. Okay, D inverse, C inverse, B inverse, A inverse. So this is a what? Is it all right? And suppose this is like this. Okay. Next is your unitary operator. Unitary operator. So, right, a linear operator. Linear operator. U is said to be unitary if its inverse, if its inverse u inverse is equal to its adjoint u dagger. Okay, so u dagger is equal to u inverse, and u dagger is equal to u dagger u is equal to I. Okay, where I is your what? I is a unit of. Okay, next point we can write down the product of two unity operators is also unit. Okay, third two unity operator is also unitary. Sorry, unitary operators. Unitary is also unique. Okay, so UV dagger is equal to UV. So UV dagger is what? V dagger, U dagger. Okay, so U, I can multiply this to V into V dagger into U dagger. Okay, so this is your I. So now U dagger into I U dagger, and these two will be again I. So this whole thing is actually I, which is a unitary operator, isn't it? Okay, this is a unitary operator. Okay. So if yeah, this, so you can see, suppose this is x, this is x. So what will be here so that I will get unity if it is inverse? So this is equal to this inverse, right? Like this is, I can write this equal to actually the inverse of this one, isn't it? Yeah. Oh, okay. Next giveaway. I think this is one of the most important ones. That is eigenvalues and eigenvectors of an operator. Okay. So see, this is suppose the eigenfunction psi, and if we operate an operator on it, that is a, that will give me what? A psi, where this eigenfunction will remain there. This a is actually what? This is called your eigenvalue. Okay, this is the eigenvalue. Suppose we are applying your unitary operator, so you will get psi. What will you get here? You will get 1 here. Okay, so eigenvalue of unitary operator is 1. How? See, this can also be written as, suppose this is a 3 by 3 matrix. Okay, so we know how to calculate eigenvalues. So if you calculate eigenvalues, that will be like what? So magnitude of this is equal to 0. So if you calculate from here, you will get lambda is equal to 1. Okay, lambda is equal to 1. So the eigenvalue is 1. Alright? Yeah. Suppose okay. Suppose A psi is equal to A psi. A is your eigenvalue, small a. Suppose A to the power n psi should be what? A to the power n psi. Okay, if I take the power of A here, A the power of also there. Okay. Another point is e to the power I a cap psi, that can be equal to e to the power I a psi. Okay. Yeah. There is another point written for a Hermitian operator. For a Hermitian operator, all of its eigenvalues, all of its eigenvalues are real, and the eigenvectors, the eigenvectors corresponding to the eigenvectors corresponding to different eigenvalues, different eigenvalues are orthogonal. For a Hermitian operator, all of its eigenvalues are real, and the eigenvectors corresponding to different eigenvalues are orthogonal. Okay. So Hermitian operator, all of its eigenvalues are real, and the eigenvectors corresponding to different eigenvalues are orthogonal. So this is one point. Mm, Next point, the eigenvalues of an anti-Hermitian operator are either purely imaginary or equal to 0. Okay. The eigenvalues of an anti-Hermitian operator are either purely imaginary or equal to 0. Okay. Next point, the eigenvalues of a unitary operator, eigenvalues of a unitary operator are complex numbers, are complex numbers of moduli equal to 1. Okay. The eigenvectors of a unitary operator has no degenerate degenerate eigenvalues are mutually orthogonal. The eigenvalues of a unitary operator are complex numbers of model equal to 1. The eigenvectors of a unitary operator has no disjoint eigenvalues are mutually orthogonal. Okay? Yeah. write a question. Consider the following two gets. Okay, psi is equal to 5 by 2 minus I, and phi is equal to 3 8 I minus 9. Okay, so the question is find psi star and psi. Is psi normalized? Is psi normalized? If not, normalize it. If not, normalize it. Okay. Then R psi and phi. Just a second. Write down R psi and phi orthogonal. Try this question. Try this question. You have 2 3 minutes. Try this. So psi is given. Psi is given as what? 5 by 2 minus I. So what will be your psi star? Minus 5 by 2 I, right? Which is the complex conjugate of it, isn't it? Which is the complex conjugate of it. And what is this? This is a bra psi. Bra means what? It will be like this. This and this like complex conjugate. So this I can write as complex conjugate. So minus 5 by 2 I, right? The complex conjugate of kit is a bra. But in like this. Okay. Now what is the next one? Is psi normalized? Check how to check whether it is normalized. If you take the bra and kid and take the inner product, if it is 1, then it is, you will say psi is normalized. Let's check it. So this one was what? Minus 5 by 2 I. This one is a what? 5 by 2 minus I. So psi is equal to how much? So it just multiplied minus 25, 25 plus 4 plus 1. Okay, this is actually 30. So 30 is not normalized. How will you write the normalized one? Just chi is equal to, just take the root over of it and divide it. That will be a normalization factor. Okay. So 1 by root 3, 5 by 2 minus 1. So this is now normalized. This whole thing is, we will say, is normalized. Is it alright? Okay. Okay. Next question is what? Are psi and phi orthogonal? So are psi and phi orthogonal? So let's see. Psi and phi. See psi and phi. Let's see whether they are orthogonal or not. Psi phi. So minus 5 by 2 I. Phi is a what? It's given 3, 8 I, and minus 9 I. So that will be minus 15 I plus 16 I minus 9. Okay, so if this is actually I plus 9. I plus 9 is not your orthogonal. Orthogonal means this should be, the inner product should be 0. Okay, then only we will say psi and phi are orthogonal, but these are not. Okay, these are, okay. Write a question, you will do it yourself. Consider a matrix A which represents an operator gets bra so A is equal to 5 b plus 2I 3I minus I 3I 8 1 minus I 1 4 psi is equal to minus 1 plus I 3 2 plus 3I phi is equal to 6 minus I 5. Okay, so first one is, I hope you have written the question. Calculate the quantities ASI, phi A, phi A, psi, and psi. Find the complex conjugate the transpose. This is a kind of a matrix question, so I hope you can solve it on yourself. The transpose and the Hermitian conjugate and the Hermitian conjugate of A, psi, and phi. Next question is calculate phi psi and psi phi. Are they equal? Are they equal? Comment on the differences between the, in the complex conjugate Hermitian conjugate and transpose of Kate's and Ross. Okay, so I hope you can solve this question. This is solvable. It's kind of a matrix question. Okay? Some theorems. Let's write some theorems regarding eigenvalues. Some theorems pertaining to the eigenvalue theorem. Pertaining to the eigenvalue theorem. First one is eigenvalues of a symmetric matrix. Okay, symmetric matrix are real. The eigenvectors form an orthonormal basis. See, of a symmetric matrix. Suppose 1, 2, 3. So this is a symmetric matrix. This one will be matching with this one. This one will be matching with this one. This matching with this one. So this is a symmetric matrix, and its eigenvalues are real. They cannot be complex. Okay. Eigenvalues of okay, of an antisymmetric matrix are purely imaginary. Are purely imaginary or zero. Okay. Next, eigenvalues of an eigenvalues of a Hermitian matrix. Okay, Hermitian matrix are real. Are real. Eigenvalues of the anti-Hermitian matrix will be skew Hermitian matrix. Eigenvalues of a skew Hermitian matrix. Skew Hermitian matrix are purely imaginary or zero. Or zero. Okay. Right. I had a question. find the eigenvalues and the normalized eigenvectors and the normalized eigenvectors of a matrix A is equal to 7 0 0 0 1 minus I 0 I minus 1. Okay, so this is your eigenvalues and the normalized eigenvectors of a matrix A is equal to 7 0 0 0 1 minus I 0 I minus 1. Okay, is it all right? Okay, so how to first of all we know how to calculate eigenvalue, right? So first of all matrix write the matrix A is equal to 7 0 0 0 1 minus I 0 I minus 1. Okay, so this is your A and this is your A. So eigenvalues of A minus lambda I is equal to 0. 7 minus lambda 0 0 0 1 minus lambda minus I 0 I minus 1 minus lambda is equal to 0. Okay, so if you see 7 minus lambda, then 1 minus lambda square minus plus I square, okay, is equal to 0 because those are two zeros, so we don't need to do it. So 7 minus lambda, this is a what, 1 minus 2 lambda plus lambda square minus 1 is equal to 0. This minus 1 cancelled out. So if you see 7 minus lambda and this is your lambda square minus 2 lambda is equal to 0. So 7 minus lambda and this is your lambda whole into lambda minus 2, that equals to 0. So lambda is equal to 7 and lambda is equal to 0 and lambda is equal to 2. Okay, so these are the eigenvalues. So we have to now find eigenvector. How do we calculate eigenvector? We calculate eigenvector corresponding to the eigenvalues. Suppose lambda is equal to 0, so I will write Ax is equal to lambda x. Okay, how would I write it? See, A is your what? What is your A? Tell me again. A is your 7 0 0 1 minus I, then your 0 I minus 1. And x is your what? X1, x2, x3. Lambda is 0, 0, x1, x2, x3. So I will just equate these two sides. So if you see, this one will become 7x1 is equal to 0 into x1, right? So x1 is 0. So the eigen vectors, this one will be 0 0 0. See, 1 into x2 minus ix3. This into this is equal to 0. So if you see that it will be x2 is equal to ix3. Okay. So I can write the eigenvector as what? What can I write the eigenvector? I can write as 0. This can be I. This can be 1. Okay. From this can be one eigenvector. Exactly like that, what you have to do is you have to calculate eigenvector corresponding to lambda is equal to 2, corresponding to lambda is equal to 7. That should be your task. Right? Because you have done it in matrices, I hope you can solve it here also. Okay? I hope you can solve this one. Write a question for your homework. Write a question for your homework. I don't have any space left, that's why I have to do it here now. Erase it. Okay, so one more. The question of four, I think. Let us find a constant alpha. Easy questions I will give you. Find a constant alpha so that so that the states psi is equal to alpha phi 1 plus phi 2 and chi is equal to 3 alpha phi 1 minus 4 phi 2 are orthogonal. Consider phi 1 and phi 2 to be orthonormal. Okay, is it alright? Next one. Next one I done. Next question was verify the matrix. Verify the matrix cos theta sin theta minus cos theta sin theta is unitary. Okay. Find its eigenvalues. Find its eigenvalues and the corresponding normalized eigenvalues. Okay. So these are two questions you please try at home. Right. So yeah. So that will be it for today. And yeah, we'll continue this quantum sessions. Also, statistical will be going on simultaneously. Okay. So that will be it for today. Thank you very much.